Blue whales. They're one of the largest creatures to have ever lived on Earth. They can grow to 100 feet long and weigh more than 150 tons.
They are bigger than any dinosaurs that you can think of.
And few have the opportunity to get this close to one.
The eyes are yay big, and it's totally a different scale. You know, as humans, we share our space with dogs, with bears, and they are big animals, but not as big as a whale.
Jean Podvin says being on this boat and close is a humbling experience. Podvin is a professor of physics at St. Louis University. He's part of a team of 17 scientists studying swimming habits of blue whales and humpback whales in the wild. They are using electronic tags and drones. Off the coast of California, they tag humpback whales. Some are tagged near Santa Barbara. And in Monterey Bay, they tag blue whales. They're using new suction cup-based tagging technology.
They install or deploy a small package of sensors that will measure their movements.
On the boat, biologists use remote controls to fly drones equipped with technology and cameras to make an assessment of the whale's size. The tags are also equipped with cameras.
So you can see the mouth opening during feeding, and then you can see the fluking action when they're swimming.
The tags are retrieved after floating to the surface. Biologists receive the signal and recover them from the water. While the real excitement is on the water close to the whales, it continues 2,000 miles inland inside a St. Louis University laboratory. Here, Podvin studies the biomechanics of swimming. He's interested in both their swimming performance and the mechanics of how whales feed. The digital tags measure the speeds and accelerations performed by whales, as well as record video of the maneuvers and their encounters with prey.
Correlating all of this performance data with body size is one of the major goals of the study. You see the swimming performance in the graphs down here, the action of the tail for the swimming. On the upper graph, which depth the whale is swimming at.
An $800,000 grant from the National Science Foundation is funding the 3-year project involving 3 universities, Podvin's team at SLU, and research teams from Stanford University and Westchester University. With new data from the tags, Podvin can carry out computational fluid dynamics simulations.
So we're talking about swim speed, roll rates, turning radius, supported with computer simulations of the water that flows by the whale.
They're designing computer software for whale research. They're beginning to generate data with the help of subscale whale figures. They're using them for 3D modeling using a 3D scanner.
And once we have this piece of software, then we can ask other questions. How much energy does a whale need to swim? How much energy does it need to eat?
From St. Louis to the coast of California, Podvin is on a journey to understand the magnificent marine mammals. It's a journey to get to the bottom of unknowns that could help their survival.
How is it that whales got so big, and how much bigger can they be? You can use the software, for example, to change the size of a whale and to change the size of its flippers and see how that affects maneuverability. But there's at some point the maneuverability decreases so much that the whale has really limited possibility for feeding. Think about the blue whale. The blue whale is so big at 100 feet that it cannot go after fish anymore. Blue whales feed exclusively on krill, which is a less mobile prey.
Podvin says the research will promote a better understanding about the evolution of whales and what the future may hold. He says this will help with conservation needs and management of resources worldwide.